Hey everybody, this is Mr. Oliver. I'm going to be going over the solution to AP Physics C Unit 3 review practice problems, and this is going to be for free response question number 1. So let's go ahead and get started. Alright, so for this first question, this is a typical experiment style question. You're likely to see one of these on your AP exam in May. So the most important part of writing your responses to these kinds of questions are truly understanding the question. So you really want to pay close attention to what it's asking and what is happening in the scenario. And so the question states, you are to perform an experiment investigating the conservation of mechanical energy involving a transformation from initial gravitational potential energy to translational kinetic energy. And the question A says, you're given the equipment below, all the supports required to hold the equipment, and a lab table. On the list below, indicate each piece of equipment you would use by checking the line next to each item. So this is a freebie, and according to the solution guide or the solution rubric for this, any objects you pick are going to be counted as correct as long as you have two specific things. You have to have a stopwatch and you have to have a meter stick. Without those two things, measuring distance and time, there's no way to complete the experiment. In my solution, I also chose a track, a cart, and an electronic balance. That was my set of equipment. Now, on question B, it does say to outline a procedure performing an experiment. And guys, outlining procedure is the experimental procedure. It doesn't say how to do the calculations later. It just says outline the procedure for the experiment. So this is like the first part of writing your procedures or your abstract. It does say to include a diagram, so we have to draw a diagram, and we got to label the equipment in your diagram, and you also got to describe which measurements you're making and a symbol for each measurement. So we're writing the entire thing. We're not just saying how you do the experiment, but it's like there should be no misunderstandings about what that procedure says, including the diagram, the measurements, and the symbols. And so for this part, first of all, I started off with setting up a track on an incline. So I sketched out a little track and I labeled it track. Okay, and I had some kind of little support here, and I have a little lab table, and I put a cart on the track, so I actually labeled that as cart. Okay, and then there are two measurements I'm going to make on this. I'm going to measure height h, and I'm also going to measure distance d. And the distance is going to be from the front edge of the cart to down here at the end of the track. So this is going to be a distance d. All right. In the procedure, it says to outline a procedure. It doesn't say to write a continuous prose form paragraph. It just says to outline a procedure. So I'm going to do that by using bullet points. And so for the first one, it says I'm going to use the balance to measure the cart mass. Use balance to get cart mass. And I'm going to make a special point to label that as M. Cart mass M. All right. My next procedure is going to set the track on an incline. Track on an incline. And measure H. Measure the height. Measure initial height. H. Okay. Next thing, I'm going to place the cart on the track. And guys, I'm kind of paraphrasing a little bit here. Place the cart on the track. And release from rest. Next, I will use the stopwatch to measure time to get to the bottom of the track. And you wouldn't use like paraphrase wording like this. You'd actually write a sentence. You use the stopwatch to measure the time for the cart to get from its initial position to the bottom of the track, for instance. Then lastly, I would say measure the distance D. That's kind of what they're looking for, right? And so for this part, I actually don't have the points. I believe this was a 4-point part here. Part C, give a detailed account of the calculations of gravitational potential energy and translational kinetic energy both before and after the transformation in terms of the given quantities measured in part B. All right, so the idea of this is to use a combination of words and equations to get your point across. And so I kind of paraphrasing this, I said that you're going to assume the initial energy is gravitational potential energy. So in somewhere in your comment, you would say E initial, your initial energy, is equal to mgh, something like that. And then you would say that the cart's going to roll to the bottom of the track, and the bottom edge of the track will count as having 0 height. So in my kind of commentary, I added comments about my final energy is going to be, or final potential energy, I'm sorry. Final potential energy is 0. Okay. I did also say, going back to this, I apologize. I also did say that because the cart is at rest, there's no kinetic energy. Okay, E is equal to 0 at the top of the hill, top of the incline. Now, I also made a comment about at the bottom of the hill, it is assumed that this gravitational potential energy will convert into kinetic energy. So I made a comment that the final type of energy will be kinetic, which has an equation 1/2 mv squared, v final squared. And then I made one last comment that said, in order to determine the final velocity, use a kinematic equation such that the distance traveled is equal to 1/2 v final plus v initial times time. And so therefore, your final velocity is equal to 2 times the distance over time, because the initial velocity here is 0. And I said that in words as well as interjecting these equations. And then the last comment you need to make is that ideally mgh should equal 1/2 m v squared, which would be 2d over t squared. And so that's the kind of process you would use to explain how to do the verification of the kinetic energy or the conservation of energy. Specifically, like I said, it's asking you to give a detailed account of the calculations of gravitational potential energy and translational kinetic energy, both before and after the transformation. And so that's kind of the idea of this, is you're explaining what's going on while also interjecting the equations. All right. And then part D, it says, after your first trial, your calculations show that the energy increased during the experiment. Well, the only way that you can increase energy in a system, and this is really a big important part for an energy kind of concept, is that if you want to change the energy, in this case it increased, in order to change the energy, in other words, have some kind of delta E, that's the idea, you're changing energy. The only way you can do that is if work is done to the system by an external force. That's the only way that you can change energy. All right. So if you look at your system, here's my system up here. I've got a cart on a track, and we're already assuming that the Earth is part of the system. The reason why we did that is because right here in our calculation for potential energy, we're talking about gravity. And so our system In our scenario here is the earth cart track system. That's what's going on. Those are our items that are in the system. The earth, the track, and the cart. All right. So the question is, how did this system gain energy whenever we've kind of already taken into account the earth, the track, and the cart? Well, the only way it could have gotten energy is if work did something to it. So where did that work come from? Maybe it was something as simple as you accidentally gave the cart a push whenever you released it. Instead of just dropping it from rest, maybe you kind of push it down the hill, in which case it'd have more energy than what would be predicted. So you got to explain how this external force is happening. So you'd say, like, for instance, pushing the cart down the hill. That would be one way for that system to gain energy, right? And then lastly, the part E says, on all other trials, your calculations show that the energy decreased. Assuming you made no mathematical errors, give a reasonable physical explanation for the fact that the average energy you determined decreased. Include references to conservative and non-conservative forces. So this is straightforward. When you hear conservative or non-conservative, you would have to conclude that, oh, energy wasn't conserved, so therefore there had to be a non-conservative force acting on it. For instance, friction. There may have been friction on the cart's wheels. Maybe where the wheels connect to the axle, that there's a little bit of friction there. You could have also made some kind of comment like air resistance. Air resistance is a non-conservative force. You could have made some kind of comment that, oh, the cart made noise when it went down the track, so maybe there was some kind of a sound being generated. Any kind of discussion of a non-conservative force, air resistance, sound, friction, etc. That's what they're looking for. All right. Now that's the end of solution 1. Check back on the channel and you'll see the solution for number 2. Thanks a lot. Bye-bye.